Being able to round correctly is the next skill we really need to have to succeed both in this course and in the college level course. How we round kind of depends on which side of the decimal point we're on. First, we're going to look at numbers that are rounding to the left of the decimal point. If I want to round 107,956,284 to the nearest hundred, the first thing I need to do is figure out which number is actually in hundreds place. In this case, I'm looking at the digit 2 is in hundreds place. So to round to the nearest hundred, everything to the left of hundreds place is going to stay exactly the same. Now, when I get to hundreds place, either my answer is going to stay 2 or it's going to round up to 3. The way I decide that is to look at the number that comes after the 2. That number is an 8. If that number is 5 or above, I don't keep the 2, I'm going to round up to a 3. Now everything between that 3 and where the decimal point would be changes to a 0. So that means I would round to 107,956,300 to be at the nearest hundred. Next question says let's round to the nearest thousand. Okay, well I have to look at my number again and I have to figure out what number is in thousands place. In this case it would be the 6. Everything to the left of the 6 is going to stay the same. Now the 6 is either going to stay 6 or it's going to round up to 7. I look at the digit to the right of the 6 and it's a 2. That number is 4 or less, so the 6 is going to stay a 6, and I fill in to the decimal with zeros. So I would round that to 107,956,000. The last one says, okay, what if I want to round to the nearest million? The digit that's in millions place is the 7. Everything before the 7 stays. Look just to the right of 7, and that digit is 9. 9 is 5 or greater, so the 7 is going to round up to 8, and everything else gets filled in with zeros, so that when I read this, it rounds to 108 million. What if I want to round to the nearest 1, the nearest whole number? Now the difference here, we're still rounding to the left of the decimal point, but I do have a decimal point. So let's be careful how we find the nearest whole number is going to be that 6 right there. Everything to the left of the decimal, everything to the left of the number we're rounding stays the same. The 6 is going to stay a 6 or it's going to raise to a 7. I look at the digit immediately to the right, it's a 2. 2 is 4 or less, so the 6 is going to stay a 6. Now anything to the right of the decimal point, I just drop. So if I round this number to the nearest whole number, it's 107,956. Not 156.000, just 956. If I want to round to the nearest hundred, I find the digit in hundreds place. It's going to be that 9. Now, because it's a 9, I might run into a little trouble. 107. The 9 is either going to stay a 9 or it has to round up. If I look at the digit immediately to the right, that digit is a 5, which means my 9 would have to round up. 9 would round up to 10. I can't put a 10 right here in hundreds place. 10 hundreds would actually be 1,000. So to round correctly, whoa, that eraser really works. To round correctly, I'm going to have to say 1, 1. My 7,000 is going to have to round up to, and that's 10, I'm sorry. My 7,000 is going to have to round up to 8,000 so that my 9 rounds up to 10. To round to the nearest 10,000, 0 is the digit in 10,000's place. The 1 would stay 1. The 0 is going to round up or stay the same. It's going to stay the same because the digit immediately to the right is 7. So that's 5 or more. Fill in the rest of the way with zeros, and we can just drop whatever's to the right of the decimal point. Now, if the number I'm rounding to is to the right of the decimal point, it changes things slightly. First, again, I have to refer back to place value from the first lesson, and I have to find the number that's in tenths place. That would be that 7. Everything to the left of the 7, no matter which side of the decimal point it's on, stays the same. 7 is either going to stay 7 or it's going to round up to 8. If I look immediately to the right, I have a number that's 5 or more, so I'm going to round that up to 8. And everything else to the right of the decimal point just drops off. So if I round this to the nearest tenth, I just stop with 10.8. If I want to go to the nearest thousandth, tenths, hundredths, then thousandths place, that would be the 5. Everything to the left of the 5 stays the same. I look immediately to the right of the 5. I have a number that's 5 or more, so the 5 is going to round up to 6. Last but not least, I want to round to the millionths. So let's count tenths, hundredths, thousandths. 10,000ths, hundredths, thousandths, millionths would be the digit 8. Everything to the left of the digit 8 stays the same. Look immediately to the right. I have a number that's between 0 and 4, so the 8 stays in 8, and I drop everything that goes to the right. If we mix it up a little bit, the nearest hundredth is after the decimal point. That would be the 6. Everything to the left stays the same. The 6 stays a 6 because if I look immediately to the right, I have the digit 2, which is between 0 and 4. So the 6 stays a 6. Now if I want to round to the nearest hundred, 100 is zeros place. So the 1 stays a 1. The 0 is going to raise to a 1, because the digit immediately to the right is 5 or above. Now I have to fill in with zeros up to the decimal point and then nothing else. If I want to do 10,000th, the TH at the end tells me I want to go after the decimal point. So tenths, hundredths, thousandths, then 10,000ths. I'm rounding to the 8. Everything to the left stays the same. And the 8 has a 4 after it, so the 8 stays an 8.